So one last question to do. We're told that we've got a micrometeorite with a certain mass travelling past the Earth with a certain speed, and we're asked what values will be measured for the energy and momentum of the particle by an observer in another system, S prime, moving relative to the Earth at 0.5 c in the same direction as the micrometeorite. And we're given a hint on how to do this. We're told to derive an expression for E prime, so that's the energy in the primed reference frame, and Px prime, so the momentum in the primed frame, in terms of E and Px, and then use this to answer the question. So let's start by deriving these expressions, and then we'll look back at the question. So as always, we've got two reference frames. We've got our unprimed reference frame, which in this case will be the reference frame of the Earth, but let's call it S. And then we've got a primed reference frame here. The primed reference frame S prime is moving at some speed u relative to the unprimed frame, and then we've got some object moving with some velocity v in the unprimed frame. In the primed frame, it's going to have some other velocity v prime. And so we know that in the original reference frame in S, the energy, the total energy, is given by mc squared over the square root of 1 minus v squared on c squared. And we know that px is equal to mvx over the square root of 1 minus v squared on c squared. Py is equal to mvy over the square root of 1 minus v squared on c squared, and pz is equal to mvz over the square root of 1 minus v squared on c squared. Now in S prime, we're going to have slightly different expressions, but very similar. E prime is going to be equal to mc squared, doesn't change, and then in this expression we'll need to replace this v squared with a v primed squared. So this is over the square root of 1 minus v prime squared on c squared. In a little bit we'll look at how we can simplify this further once we calculate this bottom term, but let's just list down the other expressions. So we've got px prime is equal to mvx prime over the square root of 1 minus v prime squared on c squared. We've got py prime is equal to mvy over prime over the square root of 1 minus v prime squared on c squared, and pz prime is equal to mvz prime over the square root of 1 minus v prime squared on c squared. Okay, so you can see that to simplify these expressions, we're going to have to work out this term on the denominator, the 1 minus v prime squared on c squared. So to do this, let's start by coming up with an expression for v prime squared. We know that v prime squared is equal to vx prime squared plus vy prime squared plus vz prime squared. Pythagoras' theorem works in all reference frames. So now what we can do is substitute in our expressions for these things here, because previously we've calculated, well, we've shown what vx prime is in terms of v. And so all of these terms actually have a common denominator. The common denominator is 1 minus u vx on c squared. And so we know that vx prime is equal to vx minus u over 1 minus u vx on c squared. So this should be squared when we square it. And so this is equal to vx minus u squared. And then the vy prime term, this is equal to vy prime is equal to vy times 1 minus u squared on c squared, square root of that, over this. So we can put that as vy squared 1 minus u squared on c squared, and then z and y are exactly symmetric. So we've got the plus vz squared 1 minus u squared on c squared. So we've now got an expression for Vy prime squared. Okay, so to substitute this into here, we're going to need an expression for 1 minus V prime squared over C squared. So we need to do 1 minus this and then divide this thing by C squared. Let's still give it a common denominator. So let's still put this 1 minus UVX on C squared, squared term down the bottom. And then to get this 1, we'll have 1 minus UVX on C squared, squared. And then we need to minus this V primed squared and divide it by C squared in the process. So let's write this as Vx on C minus U on C squared. So just dividing that by C squared and putting the C's in the brackets. Plus Vy squared on C squared, 1 minus U squared on C squared. Sorry, that's a minus because we're subtracting it here. And then this is minus Vz squared on C squared, 1 minus U squared on C squared. Okay, now to simplify this further, we need to expand these brackets. So let's have a go at expanding the brackets. We've still got 1 minus UVX on C squared squared in the denominator. So expanding this, we've got 1 minus 2UVX on C squared plus U squared VX squared on C squared, sorry, C to the 4, because we're squaring it, minus VX squared on C squared plus 2VXU on C squared. And this term will cancel this term, and then we've got minus U squared on C squared. And then we've got the minus Vy squared on C squared, 1 minus U squared on C squared, minus Vz squared on C squared, 1 minus U squared on C squared. Now, what you can see is nice is this term and this term have a common term of 1 minus U squared on C squared. And if we combine this Vx with this Vx term, that's going to have the same common term as well. And then we'll be left with 1 minus U squared on C squared. So that has a factor of 1. So we can actually pull 1 minus U squared on C squared out the front as a common denominator. So there's a little bit of room here. Let's just try and squeeze it in here. We've got minus U squared on C squared as a common factor. We've still got the common denominator, 1 minus UVX. Sorry, that's Vx on C squared squared. And then we've got this common factor. Sorry about the slight mess here. We'll go up here later. And so we've got, in this case, this 1 minus U squared on C squared is a factor of 1. And then in this case, we had to pull the Vx squared on C squared out the front. So that's minus Vx squared on C squared minus Vy squared on C squared minus Vz squared on C squared. And then minus Vx squared minus Vy squared minus Vz squared. Well, that's just minus V squared. So we've got 1 minus U squared on C squared, 1 minus V squared on C squared, over 1 minus UVX on C squared squared, and that's what this thing is. So we can see that 1 over the square root of 1 minus V prime squared on C squared is just going to be the square root of this inverted. So we will have 1 minus UVX on C squared over the square root of 1 minus U squared on C squared, square root of 1 minus V squared on C squared. And previously we were saying that 1 over the square root of 1 minus U squared on C squared is equal to gamma. So that'll make it a bit faster to write everything out. So now we've got the expression for this part, and we've just got the mc squared here. So now we can substitute this in here to simplify this expression here. So we've still got the mc squared on the top. Now we've got the gamma from the 1 on u squared minus c squared, so let's put that out the front. And then we've got 1 minus uvx on c squared over the square root of 1 minus v squared on c squared. And so mc squared over the square root of v squared on c squared, this first term, that's just e. That's what this thing was. So we can write this as gamma, and we've got an e. And then the second term is on the square root of 1 minus v squared on c squared still. We've got an m, we've got a vx. We've also, so you can see the m and vx on 1 minus v squared on c squared, that's the px. And then we've got a c squared divided by a c squared, which will give us 1. So there's just a u left there. So this is going to be minus u px. So we've now come up with an expression for e prime in terms of e. Now we're going to want to simplify this one. Okay, so substituting into this, we know we've got the m. Now vx prime, we know that that is equal to vx minus u over 1 minus uvx on c squared. And then we've got to substitute in this, which is over here. So this is equal to the gamma, and then it's the 1 minus uvx on c squared over, we've got the square root of 1 minus v squared on c squared. So nicely, this term and this term cancel out, and so we have gamma mvx, which is on 1 minus v squared on c squared, which you can just see is equal to gamma times px, and then we've got the minus u minus mu over the square root of 1 minus v squared on c squared. This term's not quite so nice, but what we can see is that e is equal to mc squared over the square root of 1 minus v squared on c squared. So the difference here is the c squared and the u. So we can actually write this part here as e times u, and then we need to divide by c squared to get rid of this c squared term here. So let's replace this with eu on c squared. Now, as the reference frames are moving relative to each other in the x direction, so u is in the x direction, we would expect py and py prime to be the same, and pz and pz prime to be the same. We can just substitute in. We've got the m. The vy prime we know is equal to vy times the square root of 1 minus u squared on c squared over 1 minus u vx on c squared. And then we've got our gamma times 1 minus u vx on c squared, which will cancel with this one. And then we've still got that root 1 minus v squared on c squared. Now this gamma and this 1 minus u squared on c squared are going to cancel each other out, and we're left with mvy over the square root of 1 minus v squared on c squared, which you can see up here is the py. And so this has not been transformed, and you can see that because pz and py are exactly symmetric, this is going to be equal to pz. So we've now come up with our expressions. We can now answer this question, but let's just write the expressions up here, and then we can clear the screen to answer our actual question. So we've got e prime is equal to gamma e minus upx, and we've got px prime is equal to px, well, gamma px minus eu on c squared. Okay, so let's clear some space now. Okay, so let's go back to our original question and carefully define everything. So let's draw the Earth's reference frame. Here's the Earth's reference frame. This is S, which is the Earth, and it has some micrometeorite moving with some speed v is equal to 0.01 c. And then we've got a second reference frame, our S primed frame. Let's draw it here, which is moving in this direction parallel to the micrometeorite with some speed u is equal to 0.5 c. And we're told that the mass of the micrometeorite in the Earth's reference frame is equal to 10 to the minus 9 kilograms. And we're now asked to calculate E prime and Px prime. Okay, so what we're going to need to do is substitute in here. So we're just going to need to work out what each of these terms is. So let's start with gamma. Gamma is equal to 1 over the square root of 1 minus u squared on c squared. And so this is equal to 1 over the square root. You can see u here is equal to 0.5 c. So this is 1 minus 0.5 squared c squared on c squared. So those cancel out, giving us 1. And so this is 1 over the square root of 0.75. And solving that on the calculator, we end up with this being approximately equal to 1.1547. Okay, next we're going to have to work out what E is. E is equal to mc squared over the square root of 1 minus v squared on c squared. And so we've got 10 to the minus 9 c squared over the square root of, now v in this case is 0.01, so minus 0.01 squared, c squared on c squared. Those will cancel, and so we end up with 10 to the minus 9 c squared over the square root of 0.9999. So solving this one on the calculator, we get 1.00005 times 10 to the minus 9 c squared joules. Now calculating Px. Px is equal to mvx over the square root of 1 minus v squared on c squared. Now Vx is equal to V because the micrometeorite is moving in the x direction. So we can write this as 10 to the minus 9 times Vx, which is V, 0.01c, over, we've got the same denominator here, so 0.9999. So solving that one on the calculator, we get 1.00005 times 10 to the minus 11 c squared. That'll be kilograms meters per second. Okay, so now we've calculated everything, so we can just combine it. So E prime is going to be equal to gamma, so that's 1.1547 times E, which is 1.00005 times 10 to the minus 9 c squared, minus U, which is 0.5 c, times Px, which is 1.00005 times 10 to the minus 11. That shouldn't be a c squared, it should just be a c. Okay, so solving this one on the calculator, we end up with E prime is equal to 1.14898 times 10 to the minus 9 c squared joules. Now we can do a similar thing for Px. So Px prime is equal to, in this case, gamma, which is the 1.1547, times Px, which is 1.00005 times 10 to the minus 9 c, times E, which is 1.00005 times 10 to the minus 9 c squared, times U, which is 0.5 c, all over c squared. So those will cancel. And so solving this one on the calculator, we end up with minus 5.66 times 10 to the minus 10 c kilogram meters per second. We would expect to get a negative answer because if we're traveling faster than this micrometeorite, it's going to look like the micrometeorite is going in the negative direction. So these seem reasonable. Let's just do one final check. Let's check that e squared is equal to p squared c squared plus m squared c to the 4 in this case. In this case, the left-hand side is equal to e squared. So that's equal to this 1.4898 times 10 to the minus 9 c squared squared. And so calculating that, we get 1.320 times 10 to the minus 18 c to the 4. And the right-hand side, we're going to need to do p squared, so minus 5.66 times 10 to the minus 10 squared times c to the 4th, because it's this c squared times c squared, which will give us the power of 4, and then plus 10 to the 9 squared, so that's 10 to the minus 18 times c to the 4. So solving that one on the calculator, we get 1.320 times 10 to the minus 18 c to the 4. So you can see there is agreement here. So it does look like we've derived these expressions correctly and answered that question.